All right, guys, here are your answers to 5-4B. Please make sure you pause and rewind, or you could even jump to the problems that you need. First couple were about a right triangle, so I'm not gonna draw the triangle, but for this one, you have a squared plus b squared equals c squared. So I'm gonna make the b the x. So actually, I could call it b. So 9 squared is 81 plus x squared, because I got to square the b. Sorry, I said I was gonna call it b, is equal to 12 squared, which is 144. I subtract 81 on both sides. 144 minus 81 is 63. So b squared equals 63. And if I square root both sides, you get the square root of 63. Now, that's not in simplest form, because you can break that into root 9 times root 7. So your final answer, b, is 3 root 7. Next one. Here you're given a squared. So when you square this whole thing, you have to square both the 3 and the root. So 3 squared is 9, and root 3 squared is 3, and 9 times 3 is 27. So 27 plus, you got to square the b, will be equal to c squared, which is 36. I subtract 27 on both sides. B squared equals 9. I square root both sides. You end up with 3. Next one. 3/4. Now, again, leave it as a fraction, because it'll help you out later when you have to use it for in other problems. A squared plus 3/4 squared. Remember that you have to square both the numerator and denominator is equal to 1 squared, which is just 1. So you end up with a squared plus, when I square the 3, you get 9. When you square the 4, you get 16 equals 1. So I'm going to subtract 9/16 on both sides. Now, in order to keep it as a fraction, I got to remember that another name for 1 would be 16/16 and minus 9/16. Or if I left it as a 1 and did this on your calculator, you would end up with an answer of, well, 1 minus 9/16 is a squared is equal to 7/16. Now, you square root both sides. So we're going to have to remember this means you square both the square root, and the 16 individually. Square root of 16 is 4. Square root of 7 is just root 7. Can't be simplified. This is the exact answer in simplest form. Next one, we're going to call, we don't know a, so we're going to square b. And when you square a square root, something that's already in the square root sign, you end up with 2. When I square the square root of 6, you get 6. So a, don't forget to square it, plus 2 equals 6. A squared, I subtract 2 on both sides, equals 4. So a equals 2. Remember, it's actually a positive and a negative 2, but negative doesn't work because a is a length. So your final answer is 2. Number 5, we know that a to b is in a 1-to-3 ratio, so I could call it x and 3x. So I know that if I square this and square this, you get x squared plus, when you square 3x, you remember you have to square both the 3 and the x. You end up with 9x squared. Together, that combines to be 10x squared, which equals this squared, which is 25. Now, if you divide by 10, you get 2.5. There's nothing technically wrong with leaving it at 2.5, but to get a nice, simpler, answer in simplest form, it's better if we're going to leave it as a fraction. So I divide both sides by 10. You could actually reduce 25 over 10, divide both of them by 5, and you end up with 5 halves equals x squared. So now if I square root both sides, you end up with root 5 over root 2. I'm going to rationalize the denominator, and you end up with root 10 over 2 as your final answer. Now, technically, if you would have left it as the square root of 2.5, that wouldn't be wrong, but this is a nicer way to put it so you can use this in other problems. Again, another problem like that, you have 1 to 2, so we're going to make a and b x and 2x. So when I square this, I get x squared. When I square this one, you get actually 4x squared. When you add them together, 5x squared, which equals c squared. C squared is this squared. But when you square those, you square the 4 and the root 3. So you end up with 16 times 3, which is 48. Divide by 5 on both sides. X squared equals 48 over 5. And if I now square root both sides, you end up with the square root of 48 over the square root of 5. Now, first of all, 48, you could do this a bunch of different ways. I'm going to simplify root 48 because I know it's root 16 times root 3. So another name for root 48 is 4 root 3. So 4 root 3 divided by root 5. I'm going to have to rationalize the denominator. And you end up with 4 root 15. Root 3 times root 5 over root 5 times root 5 is 5. And that's in simplest radical form. All of these are done the same exact way in order to know whether it's right, acute, or obtuse. And actually, in the problem, it actually asks you if it was just a right triangle. So you do it the same way. The C is always the biggest side. So I'm going to square the two smaller legs and see how they compare to C squared, which is 30 squared. So 6 squared is 36. 27 squared is 729. So 729 plus 36, you get 765. 30 squared is 900. So we know it's not a right triangle because they would be equal. But if I put the C squared first and compare them, 900 is greater than 765. We now know that this is an obtuse triangle. Okay? And in your homework, you would have written no because it's not a right triangle. Now, I'm not going to go through the other ones because you do the other ones the same exact way. Remember, if you put C squared first, if it equals A squared plus B squared, it's a right triangle. If it's greater than, like this one was, it's obtuse. And if it's less than, it's acute. All right, so here's the next one. Rectangle has a perimeter of 20 and a width of 4. So we can figure out what that rectangle is going to look like. Because if we know it's a rectangle and has a width of 4, we know the opposite side is going to be 4. Perimeter is 20, which means, so that's 8 in itself. So these two have to add up to 12, and they're equal because it's a rectangle. So we have 6 and 6. Find the length of the diagonal. So the diagonal would be the line that goes all the way across. Well, we know this is a right angle. So we can use the Pythagorean theorem. 4 squared plus 6 squared. 16 plus 36 is equal to 52. So C squared, remember it's C squared though, so you have to square C. So I'm going to square root both sides. And you get C is root 52, which I don't believe anything. Oh, I'm sorry. You could actually do root 4 times root 13. So you end up with C. The exact answer for the diagonal is the length of 2 times root 13. The altitude of an equilateral triangle is 12. So altitude would be, now here's what you have to know is that in any equilateral triangle or isosceles triangle, when you draw an altitude, it's going to split this side in half. Or in other words, it's also the median. Well, if it's an equilateral triangle and it's 12, we know that all the sides have to be 4. So this little guy right here is going to be 2. I don't know this altitude. I'm going to make it x. Oh, I'm sorry. I did this completely wrong. It says the altitude of an equilateral triangle is 12. So erase all that. We're going to make that 12. Now, we don't know the side lengths. So I can make them x, x, and then another x. However, if you do that, this little guy right here would be 1/2 of this whole side. So it's half of x. Well, rather than have to deal with fractions, another good strategy, if I make them all 2x, you can make, your sides are still equal, 2x, 2x, and 2x. And that way, this is going to be half, so that'll just be x. And now you'll see you have a right triangle, and even though you don't have all 3 sides, you have them in terms of x. So 12 and x are the legs. So 12 squared plus x squared is equal to 2x, which is the hypotenuse, squared. 144 plus x squared is equal to, now when you square both these, you actually get 4x squared. So I'm going to combine my x squareds. I'm going to subtract x squared from both sides. So you get 144 is equal to, when you subtract, you end up with 3x squared. So is 144 divisible by 3? It is. You get 48. So I divide both sides by 3. So x squared equals 48. So now I'm going to square root both sides. And if you square root both sides, you end up getting, so root 48 could be root 16 times root 3. So you get that x is, root 16 is 4 root 3. Now, once you get x, it asks you for your perimeter. Now, remember, your perimeter, your original sides were 2x, 2x, and 2x. So added together, your perimeter is 6 times x. Well, here's what x is. So if you do 6 times this, 6 times 4 root 3, you just multiply the 6 times the 4, you get an exact answer of the perimeter being 24 root 3. Diagonals of a rhombus in a 2-to-1 ratio. So this is kind of what we were talking about before. We know in a rhombus, these, I'm going to put them in blue, are the diagonals. But we know a couple things about them because you learned them in the last unit. We know there's a right angle here. We also know that in any parallelogram, these diagonals are bisected. So this and this part are equal, this and this part are equal. Well, if they're in a 2-to-1 ratio and I make one of them x and the other one 2x, I'm going to have to cut them in half in order to use in my right triangle. So rather than call all the two diagonals the length x and 2x, I can make them 2x and 4x. They're still in a 2-to-1 ratio. This times 2 is this one. But now, if this one right here is 4x, I can say, because it's bisected, they're both 2x. And if this long one is 2x, then this little one will be x, because this one will also be x. Well, now you have the legs of the triangle, and since we know the perimeter of a rhombus is 40 and all sides are equal, we automatically know all the sides are 10. Well, I can figure out what x is because I can use the Pythagorean theorem. This squared plus this squared will equal this squared. So x squared plus, if I square 2x, remember it's 4x squared, is equal to 100. 5x squared, when I combine them, is equal to 100. I divide by 5, I get x squared equals 20. I square root both sides, you get x equals the square root of 20. But I'm going to simplify that down to, this becomes root 4 times root 5, which is 2 root 5. So x equals 2 root 5. But that's not the answer. That's just what x is. We've got to remember we have to go back. And remember, we originally named these as my length of my diagonals. So 2 root 5 times, that's what x is. So 2 times 2 root 5 is 4 root 5. That's the length of one of the diagonals. 4 times 2 root 5 is 8 root 5, which is the length of the other diagonals. Okay? And the last one, if AB is x plus 3, so AB right here, x plus 3, and BC is 3x, and AC is 17, find the area of ABC. A, B, C. So we need, right here is a right angle. So all we really need to know is what x is, and I could use this and this as my base and my height. So it says that I know that this 17, this is a right triangle. These are the legs of a right triangle. So I can do x plus 3 squared and 3x squared is equal to 17 squared. So this gets a little tricky. Now 3x squared we've done before. You get 9x squared. X plus 3 squared, you don't distribute. Remember, this is where you use FOIL. X plus 3 squared means x plus 3 times x plus 3. So after you do FOIL, you get x squared plus 6x, well, 3x and then 3x combined, plus 9. I'm going to add this to the 9x squared already, and you end up with 10x squared, because it's 1x squared, plus 6x plus 9 is equal to, and then you have 17 squared. 17 squared is 289. So right now I have a quadratic because I have an x squared. I can't just square root everything because there's another x involved. So I'm going to have to move over the 289. So I have 10x squared, 10x squared, plus 6x. And if I subtract 289 on both sides, you end up with a negative 280, which equals 0. Now, all these are even numbers. So I'm going to go ahead and divide them by 2. 5x squared plus 3x minus 140 makes my numbers a little more manageable, equals 0. So now I'm going to use the quadratic formula. Remember, a equals 5, b equals 3, and c equals a negative 140. We'll do this on the next page. So b squared, which I believe was 3. I'm sorry, negative b, negative 3, plus or minus the square root of b squared, so it's 9, minus 4 times a, to go back, a I believe was 5, yep, 4 times a times c, which was, c was negative 140. All divided by 2 times a, which a was 5, so it's 10. So let me simplify this. Negative 4 times 5 is negative 20. Negative 20 times negative 140 is 2,800. So you end up getting 9 plus 2,800 square rooted, negative 3 plus or minus, all over 10. So this becomes 2,809, and I don't believe that you can take the square root of that. Oh, I apologize. You can take the square root of 2,809. You end up with 53. So you have negative 3 plus or minus 53 divided by 10. Now, negative 3 minus 53 won't work because remember we need positive answers because these are lengths. So negative 3 plus 53 is 50 divided by 10. You end up with x equals 5. Now that I know x equals 5, I can solve this because I know that this side is x plus 3. So this side of the triangle is 8. And this side was, remember, 3 times x, which is 15. So we're going to use our area formula. 1/2 the base. I could use either of these as the base. I'm going to use the 8 times 15. 1/2 of 8 is 4. 4 times 15, you get an area of 60. So the next problem, make sure you pause it and go back if you need to, is asking you if the ratio of BC to AB is 3 to 4. So BC to AB is 3 to 4. So 3x and 4x. And we know AC is 10 root 3. Find the area again. So we got to find out what x is. So we're going to do exactly what we did before. We're going to square this and square this. When you square 3x squared, you get 9x squared. When you square 4x squared, you get 16x squared. So combining it, you end up with 25x squared. When you square this, you square both the 10 and the root 3. So you end up with 100 times 3, which is 300. Now, we're going to divide by 25. So x squared equals, I believe it's 12, but let me just double check. 300 divided by 25 is 12. X squared equals 12. So I'm going to simplify this because it's root 4 times root 3 to root 3. Now that I know that x is 2 root 3, I could find the area because this is this is the base and this is the height. 4 times 2 root 3 is 8 root 3. Times 3 times this, which is 6 root 3. And then I have to, because it's a triangle, I have to multiply by 1/2. I could take half of 8 and make it 4. 4 times 6 is 24. Root 3 times root 3 is 3. So then finally, 24 times 3, because root 3 times root 3, is 72. And that's the area of triangle ABC. Hope that helps.